All right. Okay, let's start out with the best astronomy joke that I could find on the short notice. Anyway, does anybody know why the astronaut broke up with his girlfriend? He needed space. Oh, well, if I keep going, it'll get worse, believe me. So I will continue with this. As you know, we are going to be talking about, this is the last module of this. We're going to be talking about deep space photography. And of course, I am Steve Barr, and look at the man behind the curtain. Right here, and yeah, I kind of sort of struggled with this presentation because one of the things that I've noticed about deep space photography, when you start talking to people, it seems like their first intention is to make sure they confuse you as much as possible. And so I just started out with the basics, and we're not actually going to take that many pictures in the process of this, but however, I'm going to try to keep things simple so I don't scare anybody away from it. Okay, and this is actually also going to be emphasizing just one shot color with a DSLR. We're not going to talk hardly at all about astronomical cameras and everything, and we want to try and keep things basic, and if there are any questions, please interrupt me at any point. We have about 45 charts to go through, and I'm hoping this won't be quite so technical as the last one. I am okay, this has been happening. I'm a retired software and systems engineer for an aerospace company. Yep, one of the things, my credentials I'm very proud of, a Boy Scout merit badge. So, done all kinds of things in astronomy, whatever, visual, photography, photometry, spectroscopy, and probably a few other things. And outreach coordinator and a DAS trustee. Hobbies are music, which some of the people in the front found out it's a bad subject to talk to me about. So. And that is my better half, a little guy by the name of Tatters, who's at a sitter tonight. He was taking me for a walk down in Castlewood Canyon at that point. This is a little bit of my work that I have done in astrophotography from the lunar eclipse, Propeller Nebula, Satyr Nebula, Heart. Everybody probably, quite a few probably recognize this one. Anybody? Andromeda, yes. And this was Comet Neowise. That was taken from Guanella Pass. The one that I actually like more than anything is this guy right here, the Propeller Nebula, because it took multiple attempts before I ever got anything that made any sense whatsoever. And I think that was something like an 8-minute exposure with a 10-inch scope even. Tonight's agenda, we'll just talk a little bit about basic astrophotography, what John covered last week, equipment and software necessary. Some mounts, we'll talk quite a bit about both equatorial and SL mounts, polar aligning and focus, DSLR settings, imaging, stacking, and stretching. We're not going to cover that in a great deal of detail for the big reason we just will not have time to do all that. And reference materials, and we'll close up with questions. Okay. We previously learned in the first observability requires size and brightness, about naked eye observing various optical devices several weeks ago, observation planning 2 weeks ago, We have not done the hands-on session at Chamberlain yet. This is the third week in a row we've had to postpone that. Hopefully, it will work out next week, and everybody can come there. How many people are going to be coming to the hands-on session? How many people are going to be bringing equipment with them? Okay, good. Okay, we are probably going to be concentrating on teaching people how to use their equipment, and we will have a few other demonstrations also. Basic photography, and this is a recap. We have replaced photographs, replaced hand-drawn sketches with the camera, with the field of view. Well, what I did was, Dr. Bickle, you see that I took your formula from last week and I just multiplied the numerator by 25.4. So as a result, everything's in millimeters to calculate the camera field of view. Okay, and of course there is the 500 rule, which is 500 divided by the focal length in millimeters. So the focal length of 1,000 would be maximum. Exposure would be 0.5 seconds, 400 would be 1.2, et cetera, et cetera. Okay, and Earth's rotation results in celestial objects moving 1/4 of a degree per minute of RA. Note that I say RA, right ascension. And how far is 1 degree? Or 1/4 of a degree, or 1 minute of RA, right ascension. This is a field of view, 4.3 by 2.3 degrees. It was taken with this telescope, which is a 480 millimeter scope without a focal reducer or field flattener. Okay, and I took this picture just last week for this example of Betelgeuse. Okay, note Betelgeuse has a declination, it's only 7 degrees above the equator. And likewise, over here is Musita, declination 6 degrees above the equator. And everybody noticed the one is shorter than the other. Why would that be? Any ideas? Yes? That's essentially, that is entirely true, yes. A minute of right ascension is going to be the most at the equator, and as you go towards the poles, it's going to get to be less and less until right at the North Pole, it's virtually nothing. And that being virtually nothing is one of the reasons why, such as an equatorial mount, has a very hard time steering to things that's very, very close to the North Pole. Kind of sort of like a Dobsonian, for instance, has a problem tracking things that are exactly at zenith. Okay, and this is covering up my note. And what this says down here, I think what it says, note that 1 minute of right ascension does not equal 1 minute of declination. Okay, because we have 360 degrees in declination the whole way around the circle, and in right ascension, we only have 24 hours. So as a result of that, at the equator, a minute of right ascension essentially is going to be 15 times longer than a minute of declination. So, as a matter of fact, if you look at these, this would be declination or right ascension, and declination would be orthogonal to that. And you can see that the declination just didn't change much at all. Any questions on that? But this is what your As Dr. Bickle was talking about, this is what you're fighting as far if you don't have a tracking mount. Okay, patience. Okay, sketches. We started out with sketches such as in Galileo's time. These were actually made by, well, renditions of the ones made by Galileo. And we went to glass plates and then film, CCDs, and CMOS finally. Just about everything is a CMOS camera. That's complementary metallic oxide semiconductor. Is that right? I think it's semiconductor. We'll fight about that later. So why do we want to do astrophotography? If you look at some of the pictures, even if you log on to the website at the Denver Astronomical Society and look at the ASIG, our special interest group for astrophotography, you see many of those pictures that will actually exceed the pictures that that people were taking with the great observatories back in the 70s. Okay, and we can see many things that we cannot be viewed visually. On one of the previous slides of my work, none of those nebula, for instance, you would be able to see visually. And if you ever look at the Andromeda galaxy, even with unless you have a very big Dobsonian or something, like a friend of mine has a 22-inch Dobsonian, you're going to be just about limited to see a fuzzy patch. Okay. It's a lot of fun, though, to learn about the equipment and the software, and your skill level will increase with a little bit of time and a little bit of effort. And the great thing about astrophotography, you start taking pictures of these things and you start asking yourself, gee whiz, that thing looks really, really interesting. You know, could I learn more about that? And so you start looking into things like the difference between planetary nebulas and emission nebulas, dark nebulas, et cetera, and different types of stars. And yes, everything. Knowledge increases significantly, and we can branch out into other areas. If you start out with this, you might decide to go into planetary. You might just go into taking pictures of skyscapes. You can also go into things like Dr. Bickle did, go into spectroscopy or photometry, all kinds of things that you can do. And this is a warning. It can be addictive, so proceed at your own risk. Okay, I know that I probably got into photography, I don't know, maybe 8 years or so ago, and I'm lucky I'm retired because I never imagined that I would have spent all this money on this stuff. But okay. This is just a little bit of a comparison. This is a picture that was taken by a friend of mine of the Trifid Nebula, which is Messier 8. Okay, and the other picture was taken probably several years ago from my front porch, as a matter of fact. Okay, but however, with this picture, he sat there with an eyepiece and guiding it with a joystick, making sure that he didn't get off track at all for about a half hour. So if you can imagine just trying to sit there and just stare through an eyepiece, it sounds like it's nice to see something once, but keep staring at it for a half hour, you know, and I'm sorry about that, but you guys are probably going to be staring at me for more than a half hour.
How do you do that? Just track one star through a reticle?
That's what he would have been doing. He would have been just tracking on one star, a star that would be probably near the center of the field of view. Okay, but however, this is actually a film, black and white film, and of course this is digital, done with a color camera. So, but it was for amateurs to do, well, even for professionals. Back in the 1920s, when Edwin Hubble was looking at things like the Andromeda Galaxy, for instance, and looking for Cepheid variables, he had a guy by the name of Milt Humason that would sit there and track the things literally for the whole night so he could get enough so the stars would come out on the plate. I might add that this guy, Milt Humason, worked with one of the great astronomers. He only had an 8th grade education. So it's like I always say, education is not necessarily a sign of intelligence. And on that picture on the right, all I did was I turned the mount on, I went in and I ate some popcorn or watched a movie or something, and I came out, 2 hours later, and just about all my pictures were done. Okay, so what do we need to do this deep sky stuff? And we're going to stick to, for most realistic purposes, we're going to stick to a DSLR, which I have mounted now on that telescope. Okay, most of them have CMOS sensors. You'll need a computer probably to process your pictures. You can get away without a computer as far as out in the field, but it's a lot easier to have one. Telescope or some type of a lens, T-ring, a T-adapter, which we'll see pictures of those in just a moment. A finder scope or a TAURAD, red dot, etc. In my last presentation, I think I recommended the TAURAD, which is what I have right now on this telescope. Okay, camera software, and here's another nice term for you, an intervalometer. Okay, that is a good word to use in a word game. So a tracking mount, you can do these without having a tracking mount, but you're going to be limited to very short exposures, very high ISO settings. Probably some USB cables, and for photography, I recommend using a Bahtinov mask. So, anybody ever see? Do you want to pass that around? We'll see some pictures of what the Bahtinov mask does in just a moment. Since I mentioned it, what is an intervalometer, because I hate to throw terms out where I leave people scratching their head. You can connect one of these up to a camera, and you can set the exposure time, the number of exposures, the time between shots. Some allow even mode settings such as TV, AV, manual mode, etc. on the camera. It eliminates a computer connection, and the images would be stored right onto the SD card in the camera. I bought one of these things, and occasionally I've used it, but however, I would much rather just use a computer. It's just so much easier. Where these things are nice if you want to take things like daytime photography and you want to look at a flower blooming, for instance. Okay, you can set and take a picture every minute or so, and then merge everything, and you have a motion picture. Okay, the camera software, that gives you the capability, of course, to control the camera from a computer. It will perform all that stuff of the intervalometer plus a whole lot more, and you'll be able to review your photos immediately, and that is one of the problems with the intervalometer. You have a little bit of a difficult time looking at them on the SD card. Requires a USB cable or a net or an internet. Like this camera, I can hook it up to the internet and I can transfer pictures over to my computer, but it's exceedingly slow, so I like a USB cable. And some of the software that's available, the Canon EOS utility, I'm sure there's something also there for the Nikons that you can control from the, and Sony for that matter also. It's free. You're going to see a couple charts with some examples of the Canon EOS utility. This is what I started out with, and you know, it doesn't have all the capabilities that you want, but it gets you started anyway. You might be able to take some pictures and decide, gee whiz, do I really want to pursue this, or is this just a pipe dream? So anyway, you can also, from a third party, there's this thing called Backyard EOS, and also there's another product called Backyard Nikon. Has a great deal more capability. It's actually built around astronomy, and it does all kinds of different things. So you can do the same things you can with an intervalometer, plus it has focus tools and all kinds of different gadgets. There's also something of similar cost range called Astrophotography tool, which is really a fantastic tool. I really like it. If I had my choice, Astrophotography tool or Sharp Cap is what I would use. The only thing about Astrophotography tool, it has this thing that I call the CCs, the 3 C's. It has a lot of capability. Okay, but however, with that extraordinary capability also has a great deal of complexity. And since you have a lot of complexity, you end up getting a lot of confusion also. So, but once you catch on to it, it is a great tool. There's no question about that. I think I own both of them, as a matter of fact. I'll recommend the EOS utility and then Backyard EOS or Backyard Nikon. And another nice thing about APT, if you ever decide to get a little bit deeper into it, APT will also support dedicated astronomical cameras. And this is a picture from the Canon EOS utility. It's very easy. You just set everything. You can just about set everything. We're on right now auto, and we're just saving. Yeah, that is the quality of the picture we're saving. You can tell it whether or not you want to just store JPG files or just your RAW files or both of them. I normally store both RAW and JPG files. And this is actually where I started in astrophotography. I got my telescope out and I connected a DSLR to it, and I pointed a pine tree way off and I took a picture of it. And it looked like a pine tree then afterwards. And I was so excited I probably did a little dance around my front deck. I hope the neighbors didn't see me. Okay, and this is Backyard EOS, and this is actually, I took this picture also. It's a little bit overexposed, but however, it's bulb setting, the ISO setting, you can set it there, you can set whatever the daylight mode is, or it's, you said it was titanium, actually it's tungsten. Tungsten, yeah. So I'm saving both the RAW and the LP and the JPG files. The way I can know, nice thing about this tool and astrophotography, I know immediately that I'm a little bit overexposed because this is what we call a histogram, which just essentially is the count of the different pixels. And I see that I am pushed a little bit, almost up to halfway. You probably, for astronomical photos, you want it somewhere between a quarter and a third normally. So, but I was taking a entire suite. This is 3 of 5, and I was at third exposure of 5, and I was at 18, and it was a 60-second exposure. So it's a nice tool. A lot of fun to use it too. Any questions about that or any of the software? And I know all the software that you can use for, oh, yes.
So is this program like hooked to your camera? Like connected to your camera?
That program, essentially that's true. The computer is connected to the camera, yes. And as a result, yes, this is the actual picture also, the last picture that I took. So I know it's a little bit confusing right now for everybody because you're going to hear a lot of terms, a lot of different types of software thrown at you. But believe me, after you do this for like a couple weeks, you will be referring to them as easily as you order a pepperoni pizza. Okay, and this is a picture. This is one of the things that I have always argued. There are advantages to a DSLR. A DSLR versus an astronomical camera. This is the DSLR, and this was taken with a astronomical camera. Anybody know what nebula that is? I heard somebody say it. Dina, you weren't allowed to say it. Yes, it is the North American Nebula. Anybody know why? Okay, right here, what we have, okay, this is Mexico. Okay, and this is the Gulf of America. Okay, and right here we have a fat Florida. And if I use my imagination a little bit, I can even see the Hudson Bay up here. So that is the North American Nebula. And the reason why we have, if you notice on the right-hand side, the picture is a lot redder. Okay, because the thing of it is, the DSLR, unless you have the filter removed, it has a IR filter in it to block out IR light. Okay, and there's no IR filter in the dedicated astronomical camera. As a result of that, you get a whole bunch more red light coming through, sometimes a little bit more than you would really want. I think that you can do things such as get a UV IR filter and put it on them. If I get annoyed with a picture like that, that's what I do anyway. But however, the nice thing about the DSLR, again, it's kind of sort of like the Trifid Nebula. The reflection nebulas do not come out as well, I don't think, with an astronomical camera. And you have all kinds of these blue colors and different shades of colors, a lot more so than you have in this one. And the thing of it is, I will also mention, as a result of not having that IR filter in, an astronomical camera is going to be much more sensitive to light. And as a result, you won't have to take as long of exposures. Okay, If you have any scope, use that. It doesn't matter. I think I started with a scope that probably was not recommended. I think it was an ETX 90, a little MCT, which is not a good photography scope, but however, it got me started anyway. And it got me that picture of the pine tree that I told you about. So eventually, if you want to get into it, I will stress trying to get a small refractor of 100 millimeters or less. So, for instance, this guy right here is just 80 millimeters. You don't need a big scope to do a lot of great work. As a matter of fact, I have one scope I do work with that's a little bit smaller than that, 60 millimeters, and I have them the whole way up to 10 inches. And this little scope right here, I call it my workhorse. I've used it for more things than I have any of the other scope. Okay. And also, small refractor will give you a wide field of view, which in the process of polar alignment, you'll be able to find the stars that you're looking for, and also verify that a field flattener is going to be available for that particular scope. We talked about field flatteners a couple weeks ago, just essentially just looking at at a given picture from a refractor, for instance. The field will be a little bit curved, especially around the edges. And the field flattener, and normally they're focal reducers too, which means that since you have a shorter focal length, you're going to, you can decrease exposure time. Okay. Okay, and you need any DSLR tracking mount. Now I can say I prefer the gems for the big reason that's the only kind of mount that I own. So this is just a simple astrophotography rig, which actually is just sitting right there. What I wanted to do, a friend of mine, a guy by the name of Nate Peckinpah, has this rig that has so many wires that it confuses me. Okay, and I can't, why would anybody want to do anything like that but whoever he is? Filter wheels and focusers and just all kinds of stuff, and something called a computer mounted onto the scope called an ASIG, and you don't need all that stuff. Okay, this will get you started anyway. As a matter of fact, and note also that I do not even have a guide scope on this. Okay, and that previous picture of the North American Nebula that was taken with the DSLR was taken without a guide scope, and just this mount. So very reliable mount though. We'll be talking about that in a little bit more detail as far as polar aligning them, etc., for both alt-az mounts and equatorial mounts. This is the optical train. Okay, of course, we have the camera. This thing right here that Dr. Bickle talked about is a T-ring. Okay, and then what I have is a T-adapter. And I think that last week we looked at, you had a Barlow lens on that, didn't you? Yeah, this does not have a Barlow lens on it. And of course we have the telescope and a Telrad on top of it. We get everything put together and it looks like this. If anybody wants to come up and take a look at this equipment or have any questions about it, please ask. I'll do what I can to answer it. And, yep, here, note, no guide scope currently. So, again, guide scope might be something that you might want to add before too long, but however, until you spend the extra, whatever it might be, $150 on a guide scope and a $200 or $300 on a guides camera. Just make sure that it's going to be something that you're going to want to do. Okay, we have different types of tracking mounts. We have the German equatorial mounts. This with an Smith-Cassegrainian mount onto it. And an equatorial mount, that's a Meade equatorial mount. Unless you caught something on the High Point Scientific sale, you're not going to be able to buy that mount anymore, nor that telescope. And we have a fork mount over here. And then the fork mount, the way it's configured right now, is just an Alt-As. Likewise, I call these things the one-arm bandits. And I think there's at least one person in here that has one of the one-arm bandits. The nice thing about them, though, is it actually has what you call a Vixen dovetail. This is a Vixen dovetail, and you can actually take the scope out of it and put something else into it. You don't have that capability with the fork mount. Okay, and German equatorial mount essentially follows the arc of the right ascension, and it tracks in right ascension alone, unless you have a guide scope, and then it will follow declination if you get off at all. Fork mount, it will move in both right ascension and deck. Okay, but however, it will, I shouldn't have said that. I should have said it moves in alt and as. In other words, altitude, tilting up and down, and azimuth going back and forth across what could be referred to as the z-axis, rather. And that would include the one-armed bandits. The Dobsonians also, they're essentially, they move in both alt and as, and that creates field rotation. And like I said, if I will try to explain some of the terms that I'm throwing at you, so you understand them. Field rotation is the apparent rotation of a celestial body as a result of the Earth's rotation over time. Okay, that's because the camera will move horizontal across the horizon, and we'll get to that in a minute. In other words, the camera is maintaining the same position as it moves. Okay, the remedies would be use very short exposures with high ISO. And if you are using a high ISO, I'd take lots of exposures, because high ISO is like gain. And the more you increase it, the more noise you get. Okay, and you get lots and lots of exposures, and we'll talk about stacking also in a little bit. You can get a camera rotator also. Some of the rotators will keep up with the rate that you are moving. You have the wedge for a fork mount, which I haven't seen. I used to have one at one time, but the fork mount quit working, so I got rid of everything. And one of the other remedies for it with an Alt-As mount, you can either image at either the North or the South Pole. So, because of course everything at the North Pole, for instance, would be straight up, and you don't have to have anything. You can just move in azimuth and track everything very, very well. So, if you do decide to go that route, though, I am not going to go with you for the big reason I can't. This mount, for instance, will not point 90 degrees straight up. So I wouldn't be able to track anything. This is a field rotation, as you might recognize. Right here's the belt of Orion. This would be Betelgeuse, Bellatrix, and this is with the way it would track with an equatorial mount. This is the camera frame. As you can see, since it's following the arc of right ascension, let's look at Betelgeuse and Bellatrix right here. They stay in the same position the whole way across. Okay, with an Alt-Az mount, what you're going to have, again, we have Orion. Well, we're starting at just about the same position right here, but however, notice as you move, okay, you're still centered on a star that's Allenham, but however, look what happened to Bellatrix and Betelgeuse, okay, going one way. So that is the cause of field rotation. That makes sense to everybody? Yes. I don't know if I don't know if I hear the question entirely. One moment here.
Are the gray rectangles at the top rotate?
Yeah, they are changing the angle, right? And that is not getting changed.
Oh, that actually the angle, the camera is staying in a stationary position. Okay, because what's happening, for instance, if I can use this thing to demonstrate, such as, and maybe at break time, I guess I have about 40 minutes, I'm not doing too bad. See what happens, the camera rotates also. Okay, it follows the curve of right ascension. So I am not altogether sure that I'm answering your question, but why don't we talk about that in a little bit? Okay, and this is help with polar alignment and the TELRAD. I should have had this chart a little bit further away when I was talking about other things as far as polar alignment, but however, it is what it is now. Okay, and the North Star / Polaris is actually not at due north. It's about 0.7 degrees off of due north. So the way I found this gets me pretty darn close. Okay, what I do, and I might get some argument on this, I look through my TELRAD, for instance, and I think that I passed the TELRAD around and everybody saw the concentric circles. These are the concentric circles of the TELRAD. Okay, this is a ½ degree, okay, and this is 2 degrees from one side to the other. So as a result of that, right here, we are about, probably at that point, we would be about 7/10 of the way, because it would be 1 degree from the center to here, and I'm about 0.7 degrees. Okay, and to align something, what I do, I sort of draw an imaginary line. It can't be perfect because I'm just eyeballing it towards a star, the very top star of a constellation called Bootes. Okay, and I find that gives me a pretty close polar alignment. I'll still have to make some adjustments, but however, and I know some people draw a line from the North Star to this star in the Big Dipper, at the end of the Big Dipper handle called Elcade. You can do that. You can split the difference as far as that goes also. But however, I found this gets me relatively close, okay? And what I am doing also, when I say that I'm adjusting the Alt-Az in an equatorial mount, these two knobs right here, I can turn them and you'll notice it's going back and forth. Likewise, like ASIG, I can raise it, I can lower it or raise it to get everything lined in Alt and As. And a Batinov mask. Just a device to focus small astronomical scopes accurately, developed kind of ingeniously by a Russian by the name of Pavel Batinov. Just insert it onto the end of your scope, and if you're anywhere near focus, you will come up with an image, whatever, something like one of these. Like this is too far on the outside, that's too far on the inside. You want it just centered and focus until it is centered. And likewise, this is the Canon EOS utility, and this is a picture I took just to demonstrate that with the DSLR and the Batinov mask and this setup that I have right here. You'll notice that the center is pretty much, that's about as close as I could ever get anything. So, but yeah, as far as photography goes, a Batinov mask is well worth the money, I think. Okay, we have the alignment of an Alt-As mount. And this is where I'm going to sell a lot of people on Alt-As mounts in particular after you find out all the trouble it is to get one of these things, an equatorial mount, lined up. You don't really have to level everything perfectly. Well, you can balance your scope on the altitude axis, and you might need a different type of a dovetail or something on it, and a lot of them are fine the way they are, actually. If you're going to start out with an Alt-As scope, I wouldn't worry about it. Okay, you have the hand controller software connected. I steer to a star east of the meridian. I say you don't really have to start on the east. You can start on the east or west. It doesn't matter. Okay, and focus, center the finder in the main scope and confirm it's centered with the hand controller, and then steer to a star west of the meridian, center in the finder, do the same thing and confirm that you're centered, and you are ready to go and steer anywhere you want to go. Okay, because what that does, the computer software will look at the difference between the two stars, and it will essentially draw a vector to any other target that you're looking at. So it's actually that is the one thing nice about an Alt-As scope. It is very, very easy to get it aligned. And this is where I'm going to scare people away from an equatorial mount. Okay, first thing you want to do is to take the tripod and make sure that it's pointing north. Some people just use a phone application for that. I prefer to use a compass for it. I prefer to use a compass, and I also account for the magnetic offset from the compass, which is how far the actual magnetic pole is away from the North Pole. Okay, we point the tripod north, and then we level it with the adjustments on the legs, and after it's level, we can put the rest of our equipment onto it. And then we'll do a declination balance, such as right here. I can loosen these two knobs up, and I can then slide the dovetail back and forth. See, this is pretty much leveled right, pretty good right there, because I balanced it before you guys came in. Okay, and then likewise the RA balance, the right ascension balance, put it like this, and it doesn't go too far, but however, note if I had the thing right there, gee whiz. You know, that's obvious that it's going one way too far. There, it's still drifting a little bit. And I'll move it back to where my marks were, where I know it's leveled anyway, or balanced. And then you align index marks. This is a picture of this mount right here. There are index marks for declination. There's an index for marks for right ascension. Okay, do what you can to get these as close as possible. In particular, the right ascension probably doesn't, you can, if you're really close, just close enough on right ascension, it doesn't matter that much. But because the right ascension doesn't affect the altitude all that much if you move it just a hair one way or the other. Not the case with the declination. Try and get it as close as you possibly can. Okay, and okay, you align the, again, this is, these are the steps that you would go through then to do the polar alignment of an equatorial mount. Align the scope and as per several charts before, hand controller software connected, steer to a star east of the meridian, center of the finder in the main scope, and incidentally, the mount will do all this for you. But however, you're going to have to center everything. Confirm centered, then steer to a star to the east of the meridian, your second star, center it and confirm that everything is cool. And then we go and we steer to the star west of the meridian and do all of the same things again that we did with the star on the east of the meridian. But however, and then after you're done that, you can check your alignment error. What I have found, less than 30 minutes of alignment error is just fine for visual. But if you're doing photography, it should probably be less than 5 minutes. And then what you have to do, if you are doing photography, what you have to do is go back and, well, let's say for instance, if you're 30 minutes to the north, okay, what you want to do is raise the mount. So you want to go back and look at the North Star and essentially look through the TELRAD and make a reasonable guess about where 30 minutes would be, and make that adjustment. Likewise, if you're north, you raise the mount, and if you're south, you would lower the mount. Okay, and likewise, in azimuth, if you're east of the meridian, you make the adjustments to go west, and if you're west of the meridian, you go east. And you keep on doing that until you get a polar alignment that you're satisfied with. So as a result of that and all the trouble that it takes to line one of these things up, I probably talked a lot of people here out of getting an equatorial mount. What was that again?
We use the Polaris to polar align telescopes in north. What do they do in the south? They don't have a star.
They don't have a star there, no. What they do, they look at these things, and I have never done anything from the south. Let me say that. From what I understand, they just essentially try and line up with what you call asterisms, okay, which is Southern Cross would be thing, and they just try and line up. It would be it's entirely true. I always thought it would be much more difficult trying to do things from Australia, for instance. But however, there certainly are lots of great photographers come down there. As a matter of fact, I know a guy, Matt Russell. He's in the Colorado Springs Club. He images from Australia remotely. So I think that you have a very good point. It's going to be a lot more difficult. Okay, we have been going for almost an hour. Does anybody want to take a break, come up with any other questions, etc.? I think that probably we have about maybe a half hour most of this stuff remaining. So why don't we take a break now?
10 minutes?
10 minutes, 10, 15, yeah, 10 or 15 minutes will be fine. Okay, we're talking about the initial DSLR settings right now. Set the date and time. If you have a battery in your camera, or some of them have an internal battery, unless you don't use it for a long time, it will be there. Long exposure noise reduction, if you're doing things on the bulb, you want that to go off. What long exposure noise reduction does, it will take a picture, such as you're taking an image. If you want to take just an image of a galaxy, for instance, for 1 minute, it will essentially, directly after that 1 minute, it will take another picture with the shutter closed. And as a result, what it will do, it will find what they call the hot pixels and remove them from that image. But however, that is something you can do in post-processing. And as a result of that, yeah, I always set it to off. I think I did I experimented with doing that, but I just got way too impatient. Okay, set the picture to RAW plus JPG. That's my own personal preference. I know that Dr. Bickle, for instance, he will just keep the RAW.
I do the same thing.
You do? Okay. Okay, I feel better about that now. Okay, maximum image size aspect ratio. It's normally going to be 3:2 if you have an APS-C or full frame camera. White balance, I've always set it to daylight. There isn't that much difference in setting it to tungsten. I do not know what the settings for that would be on a Nikon. You know?
For nighttime shooting, it's like 3,800 Kelvin.
Okay, okay. Mm-hmm.
Daylight, if you're trying to do daylight, it's like 5,200.
Okay, and set the LCD brightness, that is the LCD display on the camera itself, to low. You will have no trouble seeing it anyway in the dark. Auto power off, never. You don't want to have the camera shut off in the middle of your exposures. Autofocus off, and in general, the mode is going to be bulb. Auto ISO off. Try the initial setting around 1600. In particular, for the people with ASIG mounts, that would probably be a good idea. 1600's a little bit more than I have ever done, but however, that's okay. I do know that some people go as far as up to like 12,080 on the ISO. Polar align accurately. Steer to 1 to 2 magnitude star. Set the camera control software to live so you can see what you're focusing. Place the batten-off mask on the scope and lens, and then focus. And then make sure you remove the batten-off mask. Don't laugh about that. That is my number one. I don't know how many times I have started out an image system, like 30 pictures, and I forgot to take that thing off. So you know I'm not perfect now. Okay, we're finally ready to image. Whatever by the preferred method, you can take an image of the focus star and just look at the JPG file and think, gee whiz, that was pretty neat. That's what I did anyway. Steer to a bright, deep object, such as just something easy. Start out with the moon, and you'll need the ISO setting at 100 for the moon, and very minimal exposure. Okay, take a 1 minute exposure and review the JPG. If it's too bright, decrease the exposure or the ISO. Too faint, increase exposure or ISO. And of course, watch for star trails on the old ASIG mounts. And this is the moon, just taken probably within the last couple of weeks. With this camera and everything, with an ISO of 100 and a 1/200th of a second with the camera set to AV. You won't be using the bulb setting for the moon especially. And target number 2 would be the Pleiades. Pleiades is the Seven Sisters, or in Japanese, somebody say it, I knew, yeah. You weren't supposed to answer that, Dr. Bickel.
I was going to answer it before the end.
I have already reprimanded Dina. Okay, known as the Seven Sisters, and I think the 7 are 1, 2, 3, 4, 5, 6, 7. Okay, and note this picture and around the edges. Okay, we have these dark areas. That's going to happen a whole lot with the full frame camera or with an ASPC camera that's a little bit smaller than the full frame. It's something called vignetting. Okay, and that can be removed from the image one of 2 ways, by either using these calibration files called flats or just cropping the image. Okay, and we're talking about stacking or stretching images. This is a little bit more of an advanced topic. We don't have a whole lot of time to spend on stacking and stretching images, but however, stacking takes multiple exposures and kind of sort of blends them together on top of each other, okay, because they have software that will line all the images. And what that does, more so than make things brighter, it will make some of the very, very dim areas brighter, but however, more so than anything else, it eliminates noise. And that is where, if you're shooting with a very high ISO setting, the more exposures that you can take, the better off you're going to be. Okay, like I said, reduces noise. And always more images are better, but however, there is a point that it just doesn't do a whole lot of good anymore, which that point's normally around 30. And stretching is something that is done after the image is stacked. It highlights the midtones in the histogram, essentially, and you can do that with Photoshop. Photoshop costs something like $15 a month right now, Photoshop Creative Cloud. You can do that also with GIMP, which is free, and another program called Serial, which is also free. There are all kinds of image processing free software out there. Again, those are some of the things you'll refer to like pepperoni pizza. Right here we have a Deep Sky Stacker. This is stacking, well, it's the stacking software that I started using anyway. Okay, I use something different now, but however, you can load up all your JPG files, and you can stack JPG files. You can stack raw files also, just all by themselves. Okay, which is what I'm doing right here. So I am stacking JPG files, and all you have to do, it says open picture files, and it will just bring up a box with a dialog that you're familiar with on Windows or Apple, and navigate over to your directory and select all the pictures that you want to process. And for that matter, I am just going to stack these. I'm not going to worry about things like dark files, flat files, dark flats, or offset bias files at this point. Note, take a good look at this image. Looks like it's very overexposed there, and that could be an artifact of just whatever's lit, whatever picture is lit, whatever image is there. It's on right now, but however, there we go, okay. And this is the image after it's stacked, okay. And you will notice that it's actually a much, much fuller image. Look at all the detail that's around the edges that you did not see in the previous picture. Okay, and somebody may comment, what happened to the color? There are certain things that you can do on Deep Sky Stacker to enhance the color somewhat in the process of stacking, or you can do it after you stretch things. So.
Let's go back one and show what it's before and after.
Patience, before. And after. Okay. That's a good comment because, yeah. Okay, thank you. And again, look at this stuff around the outside edges. What do we call that? The netting. Mm-hmm. Okay, and if we were using these flat files, that would have removed it. That would remove the netting. Mm-hmm. Mm-hmm. And these are calibration files. The dark frames, remember we talked about long exposure noise reduction. Dark files serve the same purpose. It removes the hot pixels from the image. Flat frames removes things like dust specks and vignetting. Okay, how the flat frames work, for instance, you take a picture. Okay, you have to, with the same gain settings, a lot of the same gain settings, but however, you normally take it with either a flat panel or with several T-shirts, for instance, hung over the front of the scope. And as a result, you end up with an image that is bright in the middle, and then it gets dark on the outside. And what happens then to the processing software, it essentially subtracts the things and removes the netting, to try to explain it very simply. Okay, bias frames will remove the read noise. Dark flat frames will remove other sources of light, such as amp glow, and removes unwanted light from sources such as flats. Okay, we've already seen that you can take some pretty good pictures. As a matter of fact, Soren, who owns Mile High Astronomy, he told me all he ever works with is JPGs. So, of course, if you are interested and you talk to some of the people in the astrophotography special interest group, they would think that that's a heresy. Likewise, here is the Horse Head and the Flame Nebula just stacked. Okay, Horsehead and the Flame, and that is Onatech. Okay, a very interesting star, a very hot star, as a matter of fact. But however, it's a 2-minute exposure at ISO 400, and all I did with this is just 7-stack JPG files, stretched via GIMP, and it was the first quarter moon, maybe a little bit less than the first quarter moon. But like I say, you can, and as I said at the beginning of the presentation, I'm not trying to get everything. I'm trying to avoid too much complexity, and just if I can get people or we can get people out there and taking some pictures, and they might find it somewhat rewarding. We're getting pretty darn close to the end. I don't know whether I should have even included this slide. If I was doing it next week, it probably wouldn't have been there. But these are just the different types of files, JPGs, CR2s are the Canon raw data files. What are the raw data files on the Nikon? DNG, okay. FITs, if you go on, you buy an astronomical camera, you're probably going to be processing FITs images, which has a great deal of scientific data also in them. TIFF, tagged image file format, PNG, portable network graphics, and then a couple video formats such as SER or ABI. And one of the things I forgot to tell you about Deep Sky Stacker, after you're finished stacking, it puts everything into a 32-bit deep image in a TIFF file. And most of the free software will not process a 32-bit image, but however, Deep Sky Stacker allows you the option to save it in 16-bit format. Some of the things, if you ever think about it, and this is how far you can go with this hobby, you can get a field flattener or flattener/reducer or a coma corrector if you are using a Newtonian, what I call a newt. Okay, light pollution filters in particular in the Denver area, that's going to be a great thing to have. Optolong makes lots of them along with some other ones. The only light pollutions filters I happen to have right now are the Optolong. I would start out with the L Pro, which takes out all the lights such as from high pressure sodium lights. And after you're done with that, you can move down to the L Enhance, which is actually a narrowband filter. It just looks for 2 peaks essentially in the histogram. You might want to add a guide scope and PhD2 software, which controls the guide scope, or actually controls the camera on the guide scope. Okay, PhD2, anybody know what PhD2 says? Means? No, you're not allowed. You're not allowed. Push here, dummy. And it's actually I have to agree with them, the software is very, very easy to use. I think that just out of the box, I looked at it for about 5 minutes and I thought, this is too simple. Electronic focuser possibly. If you really want to get into things, you can buy one of these things called like a GWO ASAIR, or a computer that actually mounts directly onto the telescope. Okay, but it doesn't work too well for the kind of imaging that I do, because I would have to download things from the ASI Air onto software that I can't load, so I can use software that I can't load onto the ASAI Air, so I don't have one. Astronomical camera, you might want to move into that one of these days. If you buy one, I don't think there's anything really, and a cooled camera will have a whole lot less whole lot less problems with things like hot pixels, but however, they can also be removed. And you would save probably $500 also in the purchase of the camera. Okay. Some advanced types of software like Astrophotography Tool, SharpCap, Nina, or PixInsight. I started using PixInsight, I can remember, and I got a book about it, and holy cow, I mean, the book for PixInsight is thicker than any of my astronomy books. So, and like really, it's, you know, it's like the 3 C's I told you about. Capability leads to confusion and etc. So Nina is also a good, but it's a pretty darn complex tool. But however, one thing nice about it is you can do your guiding and everything, picture taking, and control your mount from one application. And there are also these things called smart telescopes that, such as the sea stars, they can range in price anywhere from, I don't know, $5 or $6 or $100 up to $5,000. So I've seen them. But however, it's essentially, you just sit it down, has a GPS unit, and it figures out where everything is at and goes ahead and points to it. It calculates what your exposure has to do, does the processing and everything for you, which, in my mind, I guess that kind of sort of takes a lot of the fun out of it. So. Okay, we're getting pretty close to the end right now. I'll just make these suggestions for beginners. Keep it very simple and use your current equipment. Free software until you get used to it or decide what you really want to do. Things do not always work as expected, and the more things that you add onto your system, it's going to happen a whole lot more, just because of the complexity of everything. Start stacking with JPG files, add software, equipment slowly. Attend the beginner ASIG meeting via Zoom. The beginner ASIG meeting is, I think, every 2 weeks. Okay, and then they have a processing meeting that occurs also on a two-weekly basis, bi-weekly basis. And you can have some fun, and I will guarantee you're going to have some frustration. So I think a friend of mine said when I was having trouble with my equipment, it seems like astrophotography is probably 10% inspiration and 90% frustration. So, however, I will have to say that it does indeed get, as you get a little bit more experiences, you start realizing what problems you can run into and head them off at the pass, so to speak. This is the suggested reading list. Digital SLR, astrophotography. That was kind of sort of my Bible for a while. Deep Sky Imaging Primer by Charles Bracken, which is essentially the Bible when it comes to astrophotography. The Astrophotography Sky Atlas, also by Charles Bracken, or Astrophotography is Easy by Gerald Redfern. This is part of the Patrick Moore Practical Astronomy series, and there must be 100 books out there in this series, and you can find just about anything that you could ever dream of there. Patrick Moore, incidentally, he was the founder of Greenpeace. One of the two, and I don't know the other guy. And there, if I would recommend, if anybody's taking pictures, there's lots of links to different types of software, such as the Canon EOS utility, Backyard EOS and Nikon, and Backyard Nikon, Astrophotography tool, Deep Sky Stacker, GIMP. There's tutorial out there for Deep Sky Stacker. Okay, you can, a guide to calibration frames, how to do them. Okay, and also something about stretching right here on YouTube. There's all kinds of information out there. If you look, just search on YouTube for astronomical stretching or astronomical stacking. You will find all kinds of information. Okay, and the final curtain call. Any other questions about DAS, becoming a member, etc.? Okay, what do we have, Ernie?
I have several questions about the guide scope. Why would you get it? How does it work? And is it more beneficial for an alt-as mount and during equatorial?
Actually, I think that it would probably be beneficial for either. Okay, a guide scope is, the best use of a guide scope is actually for very long exposures. Like one of those first charts that I talked about when I took a picture of the Propeller Nebula. Okay, that was an 8-minute exposure. Okay, I am sure that that telescope would have drifted somewhat in the process, even in declination and right ascension. So what a guide scope will do, it will look at a star, okay, through a camera, and it will make sure that either the alt-as and alt-as scope or the right ascension and declination make sure that it is pointing at that star. So as a result of that, you're tracking on your target, because your guide scope should be in general pointing very close to where your main scope is.
Does it have its own program?
PhD 2.
Oh.
Yep, push here, dummy 2. Yeah, it would be, it's very easy to use also. When I got my first guide scope, I was a little bit amazed that it was so easy, but however, like I say, the only thing is it's probably an investment of $500 or $600 in the process. So stack some JPG files, mess around with some dark frames and flat files, etc., and then you can go ahead and then if that's working, if you want to take longer exposures to reveal deeper targets, such as very dim nebula, for instance, yeah, I think the guide scope would be very appropriate. So, you had any other questions? Okay. And anything about astronomy that anybody wants to know about? I will do my best to answer it, and if I can't answer it, I'll call Dr. Bickle. So, telescopes or DAS membership. It's about what, 30 or 35 bucks a year? Something to the order of that. Yeah. You can get a lot. What's that? How often do we meet? We meet, like just last night we had a general meeting that we have monthly. Okay. And throughout the month, though, there will be other things such as we have open houses on Saturday night, the first Saturday night after the first quarter. Okay, first quarter moon that we line up at Chamberlain. We also have things that we talked about previously, such as the Astrophotography Special Interest Group.
So you meet monthly Chamberlain?
We would meet monthly at Chamberlain, or the meeting last night was at Regis University, which is where we generally have our general meetings. As a matter of fact, we used to have them in Arapahoe Community College, but that's been, and then there was a break because of COVID, and then Regis came up. But yes, we had a very good presentation last night by a guy by the name of Wynn Pendleton, who talked about this astronomical orbiting, actually not orbiting, because it what they call Aquarium Point 2, about the same area that the James Webb Space Telescope is. And he talked about it, and I had heard a lot about that guy, Amation, but however, filled in a lot of information for me. We have some very good presentations there. So, what else? Can you think of anything else that we have? We have the open houses, we have the general meetings, we have the ASIG. Yeah, we have the dark sky site. If you have a telescope and you want to take it out to the dark sky site, you have free access to that at any time. Where's that? It is Deer Lick. Is it Deer something? Deer Trail, not Deer. Deer Trail. Probably about 50 miles to the east of Denver on 70. And you have to drive back about, I don't know, 6 or 7 miles away from 70 to get away from the lights and everything. But yeah, that's another one of the benefits.
Is that a private area or private?
At Deer,
By the club, so it's, we have, they've got a lot of stuff out there. There's some Dobsonians over there, there's a warming hut. We've got, flat concrete pads facing the door, with electrical hookups. So you can bring your laptop or whatever, if you need a power supply on your scope, that's out there. So that's a handy little facility.
we also have an observatory there.
Yeah.
And with a 14-inch Celestron scope, although I don't know, I don't know if it's in commission right now. They were having trouble with the mount, I think. Yeah. So, oh yeah, Sandstone Ranch would be another thing. We are working with Sandstone Ranch. Just found out a couple days ago that they do have some pads down at Sandstone Ranch that occasionally we have meetings and get-togethers there. Primarily, most of the people there are photographers, but however, there are visual people there too. So,
From time to time, I get a couple of the leaders of the ASIG group to go down there and help people if they're having trouble with their astrophotography gear. So you keep your eyes open for an announcement about a Sandstone Ranch with the astrophotography group. That's a good time to sort out your issues.
and it does have, it doesn't have the darkened skies, but for this area, it's pretty dark. So, yeah. Sandstone Ranch, that would be a little bit to the west of Larkspur. Probably about 6 miles, I don't know, 5 or 6 miles to the west of Larkspur, where we meet. Yeah. We have one more class, and it will be at Chamberlain, yes.
Well, they're showing it like 20% chance pre-sit next Tuesday, right?
Yeah, well, Tuesday, yep. That's like I said a little bit earlier. I am very much hoping that we can complete this whole program by Labor Day.
Next Tuesday's cloudy.
Yes.
Next Tuesday's cloudy.
Yeah. What's that?
What's the plan if it's cloudy next?
We push it out another week.
Okay.
So if it's not on the, If we don't do it on the 22nd, we do it on the 29th. If we don't do it on the 29th, we do it on the 6th.
Just clear all your.
I am not going to be here on the 6th either, Dr. Bickle. Yes. You can do that, on open house nights, okay? But it's free for any DAS member to look through it, but however, you might have quite a line to look through it. To be quite honest about it, I have never looked through the scope at Chamberlain, no.
It's interesting, it's an antique, but you know what? You get a great, just as great a view with a home telescope. It's because the glass and the optics and the technology is so much better in the last 100 years.
You'll see a bigger image because oh boy, what is do you know the focal length of that, Hunter? Would it be something like 9,000? I think the focal length something like 9,000.
Yeah, pretty far up there.
Yeah, so 20 inches, and that is a very high focal ratio also. So I don't know that it's too much good. In particular, the optics haven't been changed since it went into commission, I think in 1894. So they've deteriorated somewhat. Yeah. Mm-hmm.
6.5 feet long.
It's a very interesting thing to see. I can say that. And in general, I know that I have toured some of these, some of the older observatories, and they have some real neat equipment in there, such as, for instance, clock drives that are just essentially driven by weights. So, and I think even part of some of the things they did at the Harvard Observatory, where they made these glass plates that Dr. Bickle talked about last week, they were done by drives very similar to that. So anytime you go to anything like that, it's going to be a good experience.
I saw a pretty good sight of Mars in opposition here once.
Mm-hmm.
You saw the polar areas.
Mm-hmm. Yeah, to tell you the truth, I don't know that I have ever bothered to look for the poles on Mars. I am not much of a planetary
It
person.
wasn't just a little dot. Pretty.
Yeah, it was, I guess that does happen at times. Yeah, especially if you have good seeing also. It affects it considerably. So. Oh,
For a photographer who thinks this is a camera, is there any tripod device that I could mount this guy in, and it would do the pointing and that kind of thing for me?
Yes.
And then I would have it take the pictures for me?
Yes.
right here.
If you look on a Celestron site, they actually have cameras, they have mounts on telescopes. Yeah. That will take your,
What would the Samsung do?
it's just
I'll
basically,
show you next week. I'll show you next week. I will show you next week.
Will we have another meeting here next week?
well, we're hoping we're gonna be achieving, but this was the last of the month. Now really, really wanna get out in the field and play with this stuff.
They say it was cloudy next week. I wouldn't see a point coming here.
No, well, everybody will be notified if the event at Chamberlain is canceled. So that would be 4 weeks in a row. I thought this week was going to work out because third time's the charm, but it doesn't work that way. Yeah, last week was pretty miserable, and Actually, this week, the forecast changed from something like 90% to 70% cloud cover, so which was a little bit better, but still, you don't want to do it then.
You're just looking at the bottom of the clouds.
Yeah, I'm going to say I would say, what do you think, Dr. Bickle? 10% cloud cover, maybe 5% cloud cover?
If we had 5% cloud cover, we could still see a lot.
Oh, yeah.
Our problem is, you get the no forecast, and you're saying this, and that, look at two or three of them, and they all say, you're not gonna see much tonight.
Yeah, and keep in mind also Chamberlain Observatory is right in the middle of Denver, essentially. So you are going to, but however, what I would be hoping for is we could see enough that people here would start thinking about things and maybe want to go out to the dark site or take a trip down to Sandstone Ranch.
You see a anywhere with all that light pollution.
Get away from the light pollution, yeah. So, anything else?
We got the 7 ladies up yesterday in the space shop.
Oh, yeah?
I went up there, and it was pretty cool. That capsule's big,
Yep.
bigger than the space capsule.
Okay, and I think I'm going, if anybody has any questions about the telescope or anything, come on up. Wait a minute, wait. I am not, I don't deserve the applause. The guy that deserves the applause is Dr. Bickle, who organized everything.